In examples 3 and 4, we took an individual data value, converted it into a z-score, and then determined whether that data value was usual or unusual. That process absolutely works, but if we have a lot of data values to consider, it would be very tedious to sift through them all. So we've already established that any data value that is more than 2 standard deviations away from the mean is an outlier. What we want is a way to calculate the minimum and maximum usual values so that we can classify anything beyond that as an outlier. So we're going to look at how we calculate the min and max usual values. And our minimum usual value will be calculated as x bar, our mean, minus 2 times the standard deviation. So we're calculating what number is 2 standard deviations below the mean. And for the max, we'll calculate x bar, the mean, plus 2 times s, 2 times the standard deviation, because if anything is more than 2 standard deviations above, it's considered to be an outlier. In example 6, we're told that in a given city, the mean number of annual robberies is 139.1, the standard deviation of 7.4005. Using this information in part A, we want to calculate the minimum usual value for our data set. So we take our sample mean, 139.1, minus 2 times the given standard deviation of 7.4005, and we would get 124.299. In part B, to find the maximum usual value, we would take 139.1 and we would add 2 times 7.4005, and that would give us 153.901. That means our usual range of values will be 124.299 to 153.901. Any value outside that range would be considered unusual. In part C, then we're asked to report a number of robberies for this year that would be likely to occur. Any number inside that interval is a valid response because any number inside those boundaries is likely to occur. It's a usual value. So we could say, for instance, 125. Or we could pick a number like 151 or 142. Really doesn't matter as long as our number is between that maximum and minimum usual value. Versus in part D, we want to report a number of robberies that would be unlikely to occur. So if we pick a number that's lower than that lower bound, say like 120, that would be an unusually low number of robberies. And if we picked a value higher than that upper bound, say something like 160, that would be an unusually high number of robberies to occur. So using those two simple formulas, we can calculate that lower and upper bound and then just look at whether values are inside or outside that interval.